Yeah, sweet, cool. Yes, hello, I am Emily Mellish, and it's an honour to be here today at Data Bytes Sydney. I'm one of the Auckland organisers, so I've had the pleasure to come over here from New Zealand and be presenting to you today about how to not build a data integration. So I am the staff engineer now, got a promotion recently, at Multitudes, and we help teams deliver code faster without burning people out. A little bit more about that in a moment though. So who am I? I love horses. This is my horse, Tonic. I've been horse riding since I was a kid, really enjoy it, so that takes up most of my time outside of work. But in terms of work, I'm a data engineer and a full stack developer, plus everything in between. My background has been in startups, which means I've worn a lot of hats. I do IT, I do security, I do DevOps. Anything that needs to be done, I will do it. I've had the pleasure of working at some of New Zealand's fastest growing startups, including Rocket Lab, which is New Zealand's SpaceX. Yes, we do launch rockets in New Zealand. Halter, which is an ag tech company. They did collars for dairy cows. And now at Multitudes, where we work with software development teams to help them improve performance, collaboration, and well-being. So yes, this does mean I've worked with data for rocket engines, cows, and now developers. It's a very interesting set of sources, but it means I've had the opportunity to work with a whole bunch of different data and see a whole bunch of different problems. So before I get into the main crux of the talk, a little bit about what we do at Multitudes. So as I mentioned, we empower engineering teams to deliver better code faster, improve their team well-being with data-driven insights. In order to do that, we process a lot of data from the tools that software development teams use, such as GitHub, Jira, Pagerduty, Linear, Opsgenie, just to name a few. So we need to be able to pull this data from multiple accounts of different organizations across these. We're not just processing our own data, but the data of our customers. That means we have to be very careful about how we retrieve, store, and process that data, because we want to make sure that our customers' data stays our customers' data. We then do a whole bunch of number crunching, some magic, some AI models to deliver you some nice fancy insights and actions so we can tell you how you can reduce burnout in your team or where there are blockers in getting code out into production. Now, as you can imagine, software development teams work very differently. People use different products, they have different processes, Git, flow, etc. So this means we've had to build a lot of data integrations, which also means we've had to build a lot of data integrations. Sometimes it just feels a bit like this. You're just like, how does all this come together? I do not know. So in this talk, I want to talk about how we go about building a data integration and ideally how not to do it. We'll talk through some companies and how we integrated with them, the good, the bad, and the ugly. So first up, we want to build some sort of new data pipeline for a new insight for our customers. We tend to follow a very similar integration plan. Number one, read the docs. Very important. We need to figure out what events are available, what data is available, and how can we get the information we need for the metric. For example, how do we determine how long a pull request has been waiting for a review? Then, we want to be able to integrate with our customer's account safely and securely, so we've got to figure out how do we authorize, how do we authenticate, and how does a customer install our integration onto their account. Once we've got that sorted, it's then all about actually retrieving some data, seeing what it looks like. Doesn't necessarily match the documentation if it's out of date, so I'll always create a wiki page, document what that data looks like, what fields we can expect, etc. Then, as you can imagine, the data is often horrifically nested JSON, so we need to actually transform that into something useful that we can then use. Then we can add a whole bunch of models, our custom metrics, enrichments, etc., to make that data a bit more interesting than what it was. And then, of course, just need to QA all of that. Like, is the created at field that it's told you actually correct? Does that match what GitHub is telling you? And are the way you're calculating the metrics correct for however the customer is using that data? And then, of course, realize you're missing an edge case, your metrics are wrong, and you have to start back at the beginning. So we do this over and over and over until eventually we finally have a trustworthy data pipeline that we can deliver to customers, and we're like, cool, great, got that sorted. So through doing this process a lot of times, I have learnt many different ways to do it, and yeah, today I want to share with you how we did it with 3 particular companies. So enter the subjects. Number 1, GitHub. I'm sure you've all heard of GitHub. 2, Pagerduty, and 3, Jira. Hopefully, being Australian, you've also all heard of Jira at Latin as well. Now, a disclaimer. This is all a bit of fun. I know that some of you in this room may currently work at, or have previously worked at, one of these 3 companies. No ill intent is meant, only exasperated sighs from myself. And no companies were harmed in the making of this presentation, just my sanity. But in all seriousness, it's just a bit of jest from one data engineer to my fellow data people, you know, just talking through some of the decisions these companies have made and just roasting them a little bit. So first up, GitHub. The data that we're interested in mostly is pull requests, commits, and comments. So how long was a pull request waiting until it was merged? Who's making commits at 1 o'clock in the morning? And how are your developers giving code reviews and comments? In terms of getting the data, GitHub has quite a few different ways, but the main 3 ways are an event-based webhook or a GitHub app. So a customer would install the GitHub app, and then GitHub would send us updates as they happen. For example, we would subscribe to a pull request event, and then GitHub would send us every event when a pull request is created, updated, merged, etc. Then a GraphQL API. This allows you to query across multiple resources with a singular query. So a pull request obviously has a lot of attributes to it. Therefore, being able to use GraphQL is a quite nice way to get that data. And lastly, a REST API, of which you could say, I want a pull request, I want a comment, I want a commit. Now, unfortunately, we learned very early on that GitHub has a global rate limit. So basically, no matter how many customers we have, as multitudes, we have 1 rate limit. Therefore, any API-based implementation was ruled out pretty quickly. So GraphQL, while great, we just didn't want to be hitting rate limits and having to be batch processing data every day and then failing. And then the REST API is just worse than the GraphQL API because you have to make way more calls to get the data that you need, which left us with the events-based webhook. So in terms of actually parsing the data with the events-based webhook, once we've got it installed, GitHub sends us an event. For example, a pull request has been merged. We throw that into a webhook, into a Lambda. That then just chucks it in an S3 bucket. And that then gets pulled into Snowflake with a bunch of dbt transforms into data that is actually useful. We deliberately keep the Lambda very, very simple. So all it does is verify that the payloads come from GitHub and then throws it into the S3 bucket. And the S3 bucket data is the rawest form of data. This means that should a field change, should the schema be unexpected, we can reprocess that data should we need, and we haven't lost that event by trying to apply a schema to it. So this works really well, and yeah, has been the very first pipeline that we built at Multitudes. So the good. Thankfully, GitHub has very good documentation, so they tell you the webhook events and the types of payloads you should expect, and then what does a pull request look like. So the docs, very good, nice work GitHub. However, we can also get all data needed for an event as it happens. Sorry, I thought I was up to the bad, but I'm not. There's more good. So basically, when GitHub sends you a pull request, it also sends you all the information you need to tell things about that pull request. They don't just give you IDs, they give you the full data set. So you don't actually need to do any extra querying to know, to piece that information together. And with GitHub app, we basically don't have to deal with any gross API tokens. We love that at Multitudes. We do not want to have to store customer tokens that could then potentially be gotten by a hacker and then accessing our customers' accounts. So really great for security. You'll see throughout this talk that I avoid API tokens at all costs. The bad. So while GitHub is really great and it gives us events as they happen, there's actually no way to tell what type of event it is that they're sending you. which means your SQL looks a little bit something like this. You kind of have to rely on what fields are and are not there to determine what a pull request is, for example, which is not super great because there's lots of weird edge cases here of like a pull request also has a comment, but a comment also has a review, and so you have to know, basically have to form what type it is on your SQL alone. Really wish they had just told us this is a pull request, but no. It does get worse though. So in 2021, we discovered this lovely snippet of information. Every pull request is an issue, but not every issue is a pull request. What? Sorry? So what this means is that a data for a pull request event could come through like this, but it also could come through like this. And remembering back to what I just said before, where they do not type the events, it's very hard to tell the difference between an issue and a pull request. And I know why GitHub did this, because if you think from a developer's point of view, an issue right here looks basically identical to a pull request, right? Like there's a created at, there's a closed at, there's comments, etc. But from a data perspective, this just makes it an absolute nightmare. Thankfully, we have not yet needed to process issues, so we've basically just assumed everything is a pull request. But this was just not a great decision from a data perspective. So the final grade, honestly, GitHub, pretty good. We'll give it an A. Very nice. You know, very good documentation, a nice way to integrate. Just wish they had typed their events, please. So, next up, we have PagerDuty. PagerDuty is an incident management service. So if your app goes down, your developers are paged about that situation. They then have to get online, fix the issue, and resolve the incident. So we're interested in incidents to know how long it takes your team to resolve them. And also pages, you know, who's getting paged 3 times at 3 o'clock in the morning. In terms of getting the data, again, a few good ways. We've got the classic REST API, of course. We've got an OAuth 2.0 app, which is very nice for security. We have a webhook very similar to how the GitHub Events webhook works, which will send us information as incidents change. And then also an events integration. So, of course, REST API completely ruled out. We don't want to deal with API tokens or rate limits. No, thank you. The events integration would have been perfect, but it's only for your own PagerDuty account, not for everyone's PagerDuty account. So because we need to be able to integrate with multiple, we couldn't use this in a public way. Therefore, we use an OAuth 2.0 app. And with that, that gives us the access to then create a webhook in our customers' PagerDuty accounts, which then can send us the events-based data, which we know and love. So in terms of parsing the data, because the events are basically similar to how GitHub works, we Terraform all of our pipelines. We just spin up the same thing, Lambda, S3 bucket, Snowflake, great. However, I had learnt by this time that I probably should queue that data and like batch it up into JSON files rather than just writing each event into S3 every second. So we put a little queue in front of it, which also works quite nicely. So, the good. PagerDuty, thankfully, have a really nice normalized events-based schema. So that means every event looks the same. And they have a very handy event type. So it'll be like, this is an incident resolved event. And then you can use that to say, okay, for this data, please apply the schema. So much easier. The docs are really, really good. So made it very, very easy for us to just write some SQL, and it was a very simple process. But the bad. Despite PagerDuty's main business model to be to page people, there's actually no information on like who was paged and when. You actually cannot get this data, not even via the API. Even if I went the API token route, it just doesn't exist. We basically don't get any information when someone was paged. However, when you are paged at 1 o'clock in the morning and your phone is making a god-awful sound, you tend to get up your phone and press acknowledge pretty quickly to stop it. So we figured we could use acknowledged events to basically be a pseudo metric for what time someone was paged. It's not great, but it seems to be working pretty well for our customers. Just a very weird decision that we can't see paged events. I really don't know why. But then the ugly. An assignee of an incident is someone who has been assigned to resolve the incident. You'd think that's a pretty important field for knowing who resolved an incident, right? Unfortunately, some developers decided it would be a great idea to just clear the assignees list when the incident is resolved. So this means that once we get the incident resolved event, there's no assignees anymore. While this isn't terrible, right, we have the events, we can look back and see who was assigned when. We did not realize this at first, and our assignees were coming through as empty, and we didn't know why until we found this like obscure bit of documentation. So yeah, just not really the best from a data perspective, but I understand why you probably want to clear that field from a developer point of view. So, final grade for PagerDuty, we're going to give them a B+, you know, pretty good. I like that the events schema was normalized. We knew what to expect, but just wish they were a bit better with actually giving us page events and also not clearing the assignee list when an incident is resolved. So, you know, not bad, not as good as GitHub, but still pretty good. Next up, Jira. Again, I'm sure you're all familiar with Jira, maybe some in good ways, some in bad ways. We'll get into that in a moment. So, Jira, we're interested in stories and epics. In Jira, this is often referred to as issues. And also interested in cycles. So how long is it taking for you to do a cycle and get issues done, etc. In terms of getting the data, of course, Jira being super duper configurable, there's a ton of different ways to integrate with Jira, but the main ones we found were a GraphQL API, yep, nice, standard, great. There's Jira Connect apps, and also a new thing called Forge. So GraphQL API, again, ruled out pretty quickly. We don't want to deal with gross API tokens, no thank you. Jira Connect apps, unfortunately, is just not really designed for getting data, it seems, more for automation of Jira, which left us with Forge, which was a relatively new thing at the time, and that's basically apps that you can spin up inside Atlassian's infrastructure and then talk to a Jira Cloud account and do things that you need to do. So we elected to go with Forge. We worked with the team at the time, which was quite nice, to help us build Forge. Of course, we're in New Zealand, Atlassian's Australia, and we're able to actually talk to them and figure out how to build this. So in terms of parsing the data, again, we want to use our events-based pipeline. We have a Terraform, we're very familiar with it, it's all good. But then the Forge part is that we have a scheduled app that runs every hour for every customer inside their Jira Cloud account that's managed by Atlassian, and then queries the API for any issues that have been updated in the last hour and sends us the information. So yeah, pretty nice, standard to what we're used to. The good. It is kind of nice that it runs on Atlassian's infrastructure. You know, it's like pretty secure, it's its own sandbox. So we're not kind of passing data unnecessarily between places. And also the Forge team were really friendly. It was really nice to be able to talk to them and see what's the best ways to interact with this new product. The bad. So more than I can fit on this slide. Just to ramp through them all, Forge has no out-of-the-box auth support. Your app is actually just public on the internet, obscured by URL. You have to build your own. We have to query the API every hour for every customer, even if there aren't any changes. There's no documentation as to what an issue actually is, what fields to expect, etc. The install flow doesn't give us all the information. We had to build our own install flow and OAuth flow to verify like who's Jira and who's in multitudes. There's this other obscure REST Agile API that we didn't know about that has like other information, and just so much. But it gets worse. So this is an example of what an issue looks like. Any ideas what this field could be? Custom field 10016, cool, that seems, yeah, totally fine. This is story points. Kind of a critical thing on issues that we would love to be able to like do data information about, like how many story points, how hard was this issue. And then the second one, I mean, you could probably guess it from the name. Thankfully, it's in the name, but who knows what people call their cycles, and this is cycle. But it gets even better. These custom fields are different between Jira accounts. So while we're 10016, your story points could be 10032, and we have no way of knowing which one is the case. We, to this day, do not have story points in our product because of this reason, and every time our product team is like, hey, Jira, story points, customer asked for it, we're just like, we can't, like, I don't know how to deal with that. We did find out that there is another API, as I mentioned, Agile API, but you have to know what cycle and board the issue is on to be able to get that, so we have to basically do more calls to get the information. Not super great. So Jira gets a barely passing C+. Really hard to integrate with. The data is not the best, but we made it work, so that's okay. So our final results. We have GitHub, in with an A, well done, good. Just wish you had maybe typed your events, that would have been handy from a data schema perspective. Pagerduty, in with a B+, pretty good, just some weird decisions on what data was there. And then Jira with a C+. Now, I know there are reasons behind and company decisions as to why some of these companies basically got not good grades, Jira. But, you know, and they probably don't really think about external people using this data, and so they haven't really built it that way. And I know they've got bigger things going on. I know Jira's been around for ages. But the fact that they didn't think about it is kind of part of the problem. So we're external, so yeah, sure, but I feel like oftentimes there are problems with developers not thinking about how data teams are going to actually use the data, even within their own companies. So what lessons can we learn from this, and how can we do a better job of making a more seamless experience for our developer teams? So some lessons learned. Learn from my hard times. One, document as you go. There's just some weird things that the documentation in the source just isn't correct. And it's really helpful to know what decisions you had to make, what edge cases you had to deal with when you then need to look back in the past to see, you know, why a decision was made. Also very useful for your own docs. For example, we have our own docs for our customers about what data is available in the edge cases we made. Also very useful when you're making a talk about how not to build a data integration to use all of that information that I had already learned. Never assume anything. Even if the docs tell you that this field is defined, do not assume that. The docs could be well out of date. We assumed assignees would be correct. It was not. And then, of course, verify everything. So is the field that you're expecting to come through, is that a string? Is it what you would expect? Does it match what PagerDuty is telling you in the UI? And then also verify your metrics. Are you calculating it correctly for all the different use cases that your customers may have? Do not commit too hard to types early on. As mentioned, we try save the rawest form of data, so if we need to change something, we can. For example, you know, we like to use enum types, right? And in Jira, a status of an issue, you'd think that's pretty set, like to do, doing, done. Okay, that's not going to change. But turns out if you use Jira in Finland, we will get those fields and finish. So our data pipeline broke, despite the fact Jira said, here, this is an enum type and here are the values. If you have your Jira in a different language, those enum types completely break. So we still have finished enum types in our database to this day because, of course, changing your data type is kind of hard. And as I mentioned, save the rawest form of data, so if there are any weird stuff that the source changes, you can reprocess that and do what you need to. So in terms of working with our developers, how can we be better data people? How can we make more seamless teams? So if I could talk to Jira and GitHub and PagerDuty and actually get them to fix these things, this is what I would want to do. Agree on a schema at the beginning of, you know, a new pipeline, a new product, and document it so that everyone knows what fields to expect, how often, what units, etc. Always version control your schema and pipelines so that any changes that are made are done historically. Use CI/CD, we use Terraform, and like data catalogs, you can version your schema. Just makes it really easy for changes, and if a developer breaks something, it's not as hard to put in that change. Per what PagerDuty did, it was really nice to have like normalized event-based data, so there was a very clear schema and type, which then you can apply your nice data pipelines to. Split out the events into relevant entities. Don't just have a whole thing of JSON of all different data types. You know, make a pull request table, a commits table, a comments table, so that it's very easy to query that data how you need to. And lastly, we're all in this together. You know, we're all working at the same company, building the same product, so bring them into the process, get them to use the data pipelines, the dashboards, see how the data that they're giving you is impacting your life. Yeah, I think that's a very useful thing to do. We all just want the same thing. So I hope you've learned some things on how to not to build a data integration. We've learned over 4 years how to build these data pipelines with source data we do not control. Hopefully that's not the case for you. Hopefully you can talk to your developers. And if you're thinking, wow, GitHub data sounds super useful, but I don't want to deal with the horror show of that, then definitely come talk to me. I'm happy to have a chat, talk to you about what we do at Multitudes, and maybe provide you with a better experience than having to start from scratch and learning all of these things. I'm Emily Malish. Thank you very much.